Today we're going to look at lesson 3.4. Now, if you look at the beginning of the lesson title, you've seen these instructions or these words before. It says graphing linear equations. So I want you to think about yesterday's quiz. And when you were asked to graph linear equations, what did you have to create in order to be able to graph the equations? You remember? I had to create an X and a Y chart or an X and a Y table. All right, so that's how you've learned to graph so far. That is not necessarily difficult, but it does take a little bit of time. You do have to remember to use -1, 0, and 1, or if your X is being multiplied by a fraction, you have to remember to look at the denominator. So it's a little bit more complicated than you might have liked. So today we're going to look at how to graph linear equations that are written in standard form. So let's look at the essential question. It says, how can you describe the graph of the equation ax plus by equals c? Now this is called the standard form of an equation. So I want you to fill those circles in. All right, you've got an a times x. So a should be in the first circle. B times y, b should be in that second circle. And then c, all right, should be in that third circle. So this is what we call the standard form of a line. Now, here's why this is important. Couple reasons. Number one, this form is going to go with us for a very long time, okay? So I really want to make sure you get the standard form, commit it to memory, because it's not going anywhere, all right? It's obviously sticking around for chapter 3, but then we're going to see it again down the road. So standard form. Now, let's talk about standard form. We have ax plus by equals c. All right. The other day when we learned how to check an equation to see if it was a linear function, what was the form we had to put those lines in? Do you remember? Y equals mx plus b. And we're actually going to dive deeper into that tomorrow. All right. But I want you to see in the standard form, x and y are actually on the same side of the equation. So let's talk about a, b, and c. A, B, and C are what we call real numbers. Who can tell me or give me an example of a real number? We're talking about real numbers. We're talking about all kinds of numbers. Positive numbers, negative numbers, whole numbers, fractions, decimals. A, B, and C can be or will be real numbers. Okay, but here's what's important. A and B are not both 0. All right, let's talk about why. If that A was a 0, what's 0 times x? What's 0 times anything?
0.
So that term would be completely gone, right? So what if b was also 0? What's 0 times y? So that term would also be gone. So if a and b are both 0, we no longer have any variables, right? So a and b are not both 0. However, when a or b, so if you want to circle or, underline or, highlight or, when a or b is 0, you will have a horizontal or a vertical line. So one of those numbers, the a or the b, can be 0. And when that happens, and when that variable goes away, you now have either a horizontal or a vertical line. Now, this is the first year that I have used what you see next in your notes. I found it over the summer when I was looking for ways to teach things a little bit easier. Okay, you right now are looking at Hoy and Vux. Do you see that? Hoy and Vux. So here are those blanks. A horizontal line has a slope of 0 and an equation of y equals a number. No, that's not a hashtag. That's a number sign. Okay? So here's how we're going to remember it. Horizontal lines, that O is actually a 0. So we're putting 0 in parentheses because that's what that is. It's a 0. Okay? A horizontal line has a slope of 0. And the equation is going to be y equals a number, which means the x term has gone away. But look at Vux. A vertical line has an undefined slope, and the equation is x equals a number. Okay? Again, not a hashtag, but a number sign. So this is how, if we can commit this to memory, and I want you to highlight it once you filled in the blanks, we are going to be able to do example number 1 very, very quickly. Again, the only directions we see are graph the linear equation. But look at the equations. We have y equals 2.5 and we have x equals 5. So when the equation only has a y or an x, we're going to remember Hoy and Vux. Now look at letter A. It says y equals 2.5, 2.5, 2 and 5/10, however you want to read that. Okay, so we're focused on the fact that there's a y. So is that Hoy or is that Vux?
Hoy.
That's Hoy, right? There's your y right there. So that means our graph is going to be what kind of a line? Horizontal. Now here's the only other thing we have to make sure we understand. Y equals 2.5. So from the center of my graph, where am I going to plot my point? Up, down, right, or left? If y equals 2.5, up. I'm going to stay in the center and I'm going to go up. Now I have to be careful because of course they're counting by ones and this is 2.5. So I'm going to plot that point. And listen, we're just getting into the habit. We are going to label the ordered pair. So this is, what is the ordered pair for that point right there?
0.
Be careful. 0, right? We didn't go anywhere on the x-axis. So it's actually 0, 2.5. Okay? 0, 2.5. Now, the only other thing we got to do is draw the line. And we already said if it's y equals 2.5, it's going to be what kind of a line? Horizontal. So we draw a horizontal line. We can make it as long as we want, as long as we put those arrows on the end. And there is your graphed line. When we look at letter B, we see right away, again, one variable. This is x equals 5. So our minds should immediately go to Hoy or Vux. Now this is x equals 5. So that means we're going to have what kind of a line on our graph? Vertical. All right, it's x equals 5. So that is a vertical line. Now to graph the point, though, from the center, Kyle, where did you guys go? Right, left, up, or down? The right, because it's x equals 5, so we go right to 5 on the x-axis, and we plot that point right there, all right? When you labeled the point, what did you label the point?
5, 0.
Okay, 5, 0, perfect. And your line was horizontal or vertical? We already decided it's vertical, so you draw a straight line, you put your arrows, and you were done. That takes us into example number 2. And I actually want you to do this in your notes. I want you to put parentheses around use intercepts 2. And here's why, okay? Use intercepts to graph the linear equations, all right? Those are great directions. But what happens if I hand you a quiz or a test and all I've said is graph the linear equation? You have to begin to look for the different forms, all right? If a problem is in standard form, you are going to be able to graph it with the x-intercept and the y-intercept, all right? But if you don't recognize the form, then you might go back to doing an x and y chart, which will work, but takes a whole lot more time. So that's why I want us to put use intercepts 2, because that part of the directions might not be there come quiz or test time, all right? Now look at this. You've got the x-intercept. To find the x-intercept, you're supposed to make y equal 0, okay? To find the y-intercept, you're supposed to make x equal 0. So we're going to do that. But before we do that, let's talk about what an x-intercept and a y-intercept is. Does anybody know what an x-intercept actually is? Where the line intercepts or hits or connects or goes through the x-axis, which makes the y-intercept where your line goes through or hits the y-axis. So how many points are we talking about then? 2, all right? Because here's what tends to happen. I have people find the x-intercept and they find the y-intercept. They put them together in one ordered pair and they plot that point, okay? But these are 2 separate things. You've got the x-intercept and the y-intercept. Now, I'm going to show you 2 different ways you can do this. And again, I'm going to let you pick which way. I'm really excited about the second way because I just saw this last week when I was getting this lesson ready. But let's do the first way first, okay? So we've got 2x minus y equals 4. Right off the bat, or hopefully very soon, when you see that equation, you're going to know that's what form? What form of a line is that?
Standard.
That is standard. You've got x and y on the same side. You've got a constant over there by itself. So 2x minus y equals 4. All right, so If I want the x-intercept, I'm supposed to make y equal what? 0. So let's do that. Let's take 2x minus, I'm supposed to make y equals 0, and it equals 4. Now, what happens when I plug a 0 in? Do I have that term anymore? No. So what am I left with? 2x equals 4. Awesome. So how do I solve for x? I divide both sides by 2. So x equals 2. Now, we are always going to write our final answer as an ordered pair because it's a point. So what would the ordered pair be for the intercept of x equals 2? 2 and 0. Because we solved for 2, we plugged in a 0. So y was 0. And so that's the answer we want to box in. All right. Now, we've got to find the y-intercept, which means we're supposed to make x equal what?
0.
So we're going to take the exact same equation, but instead of x, we're going to put 0, and then we're going to bring down the rest of the problem. Now, again, what happens when I put 0 into that term? What happens to that term?
It's gone.
It goes away. So I'm left with what? Not a y. Negative y equals 4. See, this is 0, so that term is gone, and I'm just left with negative y equals 4. Now, be careful here. Y is not by itself. There is an understood what in front of it?
1.
What kind of 1?
Negative.
Negative. So how do I get y by itself?
Divide.
Divide both sides by negative 1. So what does y equal?
Negative
4. Now, ordered pair would be what?
0.
0. Good. The x was 0 this time, and the y came out to be negative 4. Now, we plot our points. How do we plot 2, 0, starting in the middle? Go over, though. Is that right? Is that left? Right, because it's a positive 2, and we stay right on the x-axis, because it's the x-intercept. Okay? We label it, so we label it as 2, 0. And then how do we plot 0, negative 4 from the center? Stay in the center and go down on the x-axis. And again, we're labeling it 0, negative 4. All right? So we draw our line very carefully. Make sure it goes through. Make sure we have our arrows on both ends. And we're done. When we created a table yesterday, how many points were on our line each time? 3. Okay? So already this is easier because we only have to plot 2 points instead of 3. All right? Now, would an X and Y chart work? Absolutely. But why would we do that? If we recognize that the problem is written in standard form, we can quickly find the X and the Y intercepts and plot those and have our line graphed. All right? So that's what we're trying to get you to recognize and understand. Now, I told you there was a second way that I learned to do this. All right? And you're going to love it. It's so simple. I can't believe I haven't thought about it before. All right? I want you to take your hand, your finger, whatever, and I want you to look at letter B. All right? The problem is standard form. You have x plus 3y equals negative 9. If I tell you that I want you to find the x-intercept, which variable do you want to go away? So take your hand and cover up the y term. Now, what happens when I cover up the y term? What am I left with? Write it down. So we're not getting rid of all the work, but we are keeping ourselves from having to plug in that 0. Now this one is already solved. X is already by itself. So what's the ordered pair? Negative 9, 0. All right, very good. Now let's do it again. This time we need the y-intercept. So which variable do we need to go away? So cover up the x with your hand or with your finger, and what are you left with? 3y equals negative 9. 3y equals negative 9. How do you solve for y? You divide both sides by 3, and y equals negative 3. And what would the ordered pair be for that one? 0, negative 3. Isn't that incredible? Now, we're not taking away all the work, but we are taking out the step where we had to plug the 0 in. All right? Isn't that genius? Graph negative 9, 0. From the center of the graph, where do we go? Right? Left, up, down. Left, okay? We go left to negative 9. Now, that's going to take us right to the edge of our graph. Okay? And we're going to label it negative 9, 0. And then how do we plot 0, negative 3 from the center?
Go down.
Down to -3, and again, we're going to label it 0, -3. All right, we draw our line. We try to do this as carefully as we can because Ms. Johnson is not the best drawer of lines. We put our arrow on the ends, and we are finished. Now, let's look at intercepts in a real life situation. You lose track of how many 2-point baskets and 3-point baskets a team makes in a basketball game. The team misses all of the 1-point baskets and still scores 54 points. The equation 2x plus 3y equals 54 models the total points scored. Now, let's go ahead and underline the equation. What do you notice right off the bat about that equation? It's in standard form. Very good. All right. It says x is the number of 2-point baskets and y is the number of 3-point baskets. Find and interpret the intercepts. Now, let's find and interpret the intercepts. So let's bring the equation 2x plus 3y equals 54. Now, let's find x first. If we're going to find the x-intercept, which term are you covering with your hand? You're covering the 3y. So that leaves you with what? 2x equals 54, which means how do we solve for x? Divide both sides by 2, and x equals 27. Now, as an ordered pair, that's going to be what? 27, 0. Now, let's talk about what we've just learned. Interpret that ordered pair. Keeping in mind that x is the number of 2-point baskets and y is the number of 3-point baskets. So interpret that for me. The team scored 27 2-pointers and 0 3-pointers, according to this first intercept. So that would be you found the intercept, and that is how you would interpret the intercept. All right? The team scored 27 2-pointers and 0 3-pointers. Now, let's find the y-intercept. So we write the same problem down again. We have 2x plus 3y equals 54. This time we want the y-intercept, so which term are we covering up? The 2x, which leaves us with 3y equals 54. And how do we solve 3y equals 54? We divide by 3. Very good. So y equals 18. Very good. Now, as the ordered pair, it would be written 0, 18. So someone raise your hand and interpret this intercept for us. According to this intercept, the team scored 0 2-pointers and 18 3-pointers. Okay? So what would be the final answer that we would write down? Because it says find and interpret. So we have found them. What would be the final answer that we would write down? She said they scored 27 2-pointers and 18 3-pointers. But hold on. Think about that. What's 27 times 2? That's already the 54 points they scored. Okay? What's 18 times 3? Okay, so you can't put these two things together. They're two separate possibilities. Does that make sense? And that's okay, because that's the mistake that gets made. That's you taking the 2 points, putting them in one ordered pair, and trying to plot 1 point. All right? So here's the final answer that you would write down. You ready? I don't have room up here, so just listen to my voice and write it down. The team either scored 27 2-pointers and 0 3-pointers. The team either scored 27 2-pointers and 0 3-pointers. One more time. The team either scored 27 2-pointers and 0 3-pointers, or they scored 0 2-pointers and 18 3-pointers. So this is not an and situation. This is an or situation. The team either scored 27 2-pointers and 0 3-pointers, or 0 2-pointers and 18 3-pointers. And that's lesson 3.4.